Good afternoon, everyone, and welcome back. After a wonderful session by Saurav Singh, we now have the next workshop in emerging era of AI-enabled, physically simulated, and industrial-scale virtual worlds. In this workshop, we will track developments and trends in the virtual worlds, perspectives across industries, highlight the role of new era 3D design collaboration and world simulation in enhancing the capabilities of businesses and organizations worldwide. We will also discuss real life use cases in digital twin modeling the digital representation of a physical object. To conduct this, I would like to invite Unnikrishnan AR, Head Developer Marketing at NVIDIA, Sashikumar Ramchandran Nair, Senior Solution Architect at NVIDIA, and Mario Viviani, Developer Relations Manager at NVIDIA Omniverse.
Hi, hey, everybody.
Hi, welcome. Welcome, Sashi.
Thank you, Ruja. You can hear me?
Yes,
Okay, we can start.
yes, we can begin right away.
Thank you, Ruja.
Thank
Thank
you.
you, Nascom, also for this opportunity. We're really excited to be here. As Ruja has mentioned, have my colleagues Shashi and Mario on this presentation to join along with me. They're currently on backstage, and I'll be requesting their help as and when I reach the portions where they can really help me out. What I wanted to cover today is to talk about the amazing era we are in, where we have the capacity currently to get AI-enabled, physically simulated virtual worlds to support us in every aspect of our life, particularly in the business environment. The incredible advances of AI and 3D graphics have laid the foundation for this. It's the next computing platform, the next big evolution of internet, the metaverse. I wanted to and take you through this presentation where we talk about this and then maybe have an opportunity to discuss some of the components also with you. So I'm hoping our my screen is visible currently. Rucha, if you could give me an indication that screen is clearly visible, that'll be good because I currently can only see the screen, neither the backstage because I'm presenting on full screen now. Rucha, you're there? Hello. Sorry, I can't hear you now. Only gone. Um, Rucha, you're oh great, and you can hear me?
Am I audible to you only?
Yes, you're currently
Yes,
audible.
yes.
Yeah,
Yes,
okay.
the presentation is seen clearly.
Okay, perfect. Thank you.
Yeah, thanks.
Okay, great. So let me redo this again. Okay, so like I said, I have Shashi and Mario to support me on this. What we will talk about is the next evolution of internet, like I said, which is what in the metaverse is all about. So internet, as you know, was commercialized around 2 decades ago. It was about web pages which were hyperlinked over a network. Decade ago rather, this evolved into cloud services which was connected to applications. The way pages got connected to applications, and you could then with the evolution of the mobile internet, you could enjoy these applications mobile internet also on mobile devices. Now web 3.0 is here. The metaverse is internet in 3D, a network of persistent rather virtual worlds interconnected and interact, enabling us to interact with it by enabling us to portal into that 3D world with haptic devices, augmented reality devices, and virtual devices. Metaverse will extend 2D web pages into 3D spaces and world. Hyperlinking will evolve into hyperjumping between the 3D worlds. In this new extension of the internet websites will become interconnected 3D spaces akin almost to the world which we are currently living in and experiencing. Metaverse applications, as you can imagine, is already here. They have been assisted by the IoT, AI, 3D devices, AR, and other devices, which has evolved over the evolution of the mobile internet. But now you're incrementally finding full-fledged metaverse applications from across board industries coming out. Almost all the goods incrementally will now get produced, simulated in the metaverse. You will have interiors shown to you by architects and design firms in full metaverse capabilities. Telcos are experimenting with the digital twins of the cities to identify and see how their networks performing in the digital twin before rolling out and optimizing their networks. Every factory is thinking about creating a digital twin of their factory to optimize their logistics, the robots inside the factories, and the human interactions within the factory. We have full-fledged cities getting simulated as digital twins of the cities. You have scientific digital twins happening, climate modeling. NVIDIA itself is building a full-fledged digital twin of the Earth. Um, if you go through this evolution, you'll find just like internet needed a computing platform of the network and the underlying computing engine for it, the metaverse also needs a new computing platform and an architecture to support it. This new platform will also will need new standards to support that architecture. Many of the virtual worlds which will be created will be reflections of the real world. Many of them will go beyond the real world so that you can have more fun with it, which crosses over the physical laws. But for a typical digital operation of a factory, you'll obviously would want that to really simulate the physics of the actual materials and the physical properties of that material so that it reflects the actual reality of the material and its properties. You will be able to portal into this metaverse with XR devices and robots who will be able to interact from the metaverse into the physical world by putting intelligence into it and getting them to interact with us in the physical world. So you will portal into the digital world using haptic devices, AR devices, and VR devices, and you will have the robots interacting with us from the metaverse where they portal out of the digital world and into the physical world. Now, the evolution of the internet was over a period of multiple decades now. It evolved into the current evolution of it was not really predicted, right? You didn't have an idea of how it will grow. Same thing I think will happen with metaverse. You will have the metaverse evolving organically, and exploding its uses and the possibility of it being applied in many ways. It just is not so easily predictable, but we definitely know the foundations required for it. Um, the first and primary thing which you will need is a standard. And we think from NVIDIA's side, and as we see the developments across the world, that you need an open, extensible way to describe all things in the virtual world of the metaverse. Just like HTML served that purpose in the case of 2D web, you will need a standard. HTML was the standard of the language of the 2D web, and USD, we think, is the standard language which will be the most ideal candidate for what will be required in the virtual world. USD was invented by Pixar, and they did this for creating the full screen description of their motion pictures in the entertainment industry. This has got extended now to every spectrum, and we think it is more than a static file format. It is a compositing engine with APIs for compositing, editing, querying, rendering, collaborating, and simulating virtual worlds. USD is unique. It's giving 3D the ability to work in non-destructive ways at layered workflows. The framework is highly extensible, providing the ability to build custom schemas for the specific virtual worlds which you'll create. Just like HTML grew from HTML 1.0 to currently what we're having as HTML 5.0, we think the USD will evolve. From the time when USD was introduced to today itself, we have seen the amazing evolvements of USD, which I'll have my colleagues describe in detail to you. But NVIDIA, from its side, has put its might behind making USD the standard. The platforms which we have built to support creation of virtual worlds, Omniverse, is built on USD as a foundation. It's an extensible world which we have created for you with USD as the foundation for doing it. USD, as I said, is quickly evolving to become the world description for 3D space. It's a system for dynamic, procedural, and real-time creation and manipulation of the virtual world. We have a long view on this, and I think we are fully committed to support the evolution of USD as a standard. Now, virtual worlds, as you can imagine now, and as you are seeing and interacting with it, is essential for every industry. NVIDIA, on its part, has built a platform for supporting the creation and collaborating with the virtual world called Omniverse. Grounds are built by us to support this across the ecosystem. Architecture, engineering, construction firms need metaverse now to support their construction and its operations. Every single project which you can think about is multi-million dollars of the large scale. Before they go into full-fledged production of it, building the construction of it, and planning the operations of it, they would want and they are building digital twins to support that. True for media and entertainment. Most of the media creation which is currently having is created using full-fledged sets in digital mode. And then the amazing evolution of the game environment, which you have seen, almost giving us this real-time effect of 3D effects and capacity to interact with it in real time, and a visualization which is so scintillating. Every product which you can think about will be manufactured and simulated and operated in the digital twin environments moving forward. They already started it. Science will need digital twins to visualize large phenomena, including climate change or weather modeling, or for that matter, heat exchanges or wind farms. Anything which you can think about which needs high-end simulation would need to be visualized and understood and interacted with. And hence, scientific visualization will demand the requirement for it to be in metaverse. Industrial automation and robotics, the robots will need to be trained in the metaverse to operate in the physical world, which they would want to get the comfort and the necessary locomotion which they need to operate in the physical world. That confidence will really come by operating them in a simulated world. We just won't be able to put them in production in a physical world without getting them trained. So entire industrial automation and robotics would need digital twins. Applies for manufacturing in the industrial area also. In order to create this virtual world, and what sort of got the big bang of it was essentially a confluence of enabling technologies. The first thing which enabled it was the capacity to have graphics in real time to simulate to physically accurate and physically accurately simulate the environment around it. NVIDIA, as you know, has been a pioneer in its graphics evolution. Over the last 4-5 years, we've evolved our RTX technology to now support it with neural graphics and give you physically accurate simulation capabilities. That is the first component which enabled the big bang of metaverse. The second thing which you needed was then scalability of the underlying compute to support the full-fledged digital twins, whether it's a city or a full factory. So you needed data center compute capable of scaling to support the scalable simulation. And third, obviously, was a standard which I said was required for anything to interact with it. And USD is evolving as that powerful asset interchange standard. AI, to move forward in order to realize its full potential, will need the metaverse, and the metaverse will need AI to power it. So it's a synergistic relationship. The entire the demand for simulation of the robots, of the various components which AI wants to train itself on and learn, is creating a demand for simulation. And that's in turn driving the requirement for the metaverse. These four enabling technologies in RTX enabled graphics simulations capable of giving you physically accurate simulation, data center capable computing, USD as the interchange platform to support the asset interchange on this, and AI is the enabling technologies which enable the capacity for the virtual worlds to be created and the big bang for it. Everything that you can think about, including robots, will become smarter. Applied AI and digital twins will be essential, like I was mentioning in earlier slides, for every single industry which you can think about. Everything which will first be built will be first simulated in the virtual world. And this is very easy for us to imagine, right? The capacity, we have been doing it, but the capacity for doing it in the level of realism and the level of physically accurate simulation capabilities which reflects the real world is now here. And hence everything which will be built will be first simulated in the virtual world. It's a simple cost of economics also. Doing it in the real world on real production will be far more costly and in many cases destructive than simulating it and trying it out first. Everything that moves will be autonomous. And in order to make them move in that physical environment, you better try them out in a digital environment so that you can give them the capacity to interact with the actual physical environment in its multiplicity of ways. You would need to simulate these environments because training them in a physical environment will just be impossible. Neither will you have actual data to get them trained. So you would need to create simulated environments to get them understand the environment in its multiplicity of favor. For example, in a lighted environment or in a dark environment, in a condition which is in with snow, without snow. For example, the case of autonomous device. Um, you need to the industry would need to build this and the creation of the virtual worlds capacities and underlying technologies layer by layer. NVIDIA, as the core engine behind both the graphics and the AI for it, has been building this layer by layer to support its evolution and capacity to realize a fully realized metaverse. Open standards, which will evangelize the open source technology and ensure that everybody who can collaborate in the ecosystem can collaborate with the same standard, is the first component of this. And like I said, USD is fast realizing their potential. It's becoming the standard for creation of the virtual world. You need simulation technologies, simulate materials with their actual physical properties and their interaction capabilities, all with to on of the real physics of it, their behavior to be the similar as in the physical world. You need underlying technologies which enable the simulation capabilities. You need AI both inside the metaverse to support you, to navigate for you, to interact with you as an avatar, and also to operationalize and to create the intelligence for the metaverse virtual world environments. So you need AI as the third enabling layer. And then you need specialized architecture built compute engines to support the execution of and visualization of the in the metaverse, which needs to be hyperscalable systems. And we've got built custom built systems for supporting that called NVIDIA OVX, which scales to demand required by the digital twins and the full scale industrial metaverse environments. This slide, we're trying to show to you the building blocks of the metaverse from a creation to operation perspective of a, let's say, a virtual world, in this case, a factory digital twin. On the left hand side is the design asset and 3D assets, which will be in the environment, and the tools which will connect 3D architects, artists, and the assistants on it. So if you look at the block diagram out here, you will have the industrial CAD design components where the CAD designers put that into the metaverse environment, and using a common standard like USD, they will interact with the core, the scene compositing environment, and you will have the factory floor CAD connecting to the same environment, again using the same USD environment. You will have then the underlying tools, the materials definition language, so that you can define the materials in their physical properties as accurately as possible. You will have a capacity to build physical realism for the interaction of the objects, and NVIDIA's tools to support that as physics. You'll have the interchange standards core engine underneath that. You will have the graphics component to support graphics engine to support the simulation of these things in real time. And then you will have AI to power them and get them to interact with the virtual world. And then you will have tools to support, for example, the robots, and in the simulator environment, a gym for them to train and get themselves accustomed to operating and working in this digital environment. You will need to do the same thing for training the digital humans in the same environment. You would rather have the factory planning tools like Bentley or any of the tools which you have to interpolate into this so that you can build that factory environment and plan for it. This is the creation to the operational environment block diagram of the typical digital twin in a factory environment. Now, if you add these components in place, you can realize a digital factory. And companies across the world are starting to build these operations. Many have reached the level of efficiency to create a fully realized digital twin of it. BMW, as you know, is an amazing company. This company produces around 2.5 million cars and automobiles in a year. I think approximately a vehicle per second. 99% of this devices, vehicles rather, are customized. It's pretty much the most amazing custom built company in the world. They have realized a digital twin factory. In the next video, which I'll play immediately after this slide, you will see the realization of that digital twin factory. And I'll have my colleague Shashi giving you a voiceover explaining each component of this digital factory and how it collaborates and enables the BMW team to in their operations and logistics. Um, um, Team, can you please get Shashi on board as I play this video so that he can speak over this and then move forward from there? Thank you. Shashi, you are ready to speak?
Yes.
Okay, thank you.
Hello, once again. What we are going to take a look at is an example of how large-scale virtual worlds are created. What you see here is a simulated assembly line of BMW. For the first time, BMW was able to simulate their entire assembly line with assets from different software platforms, including very complex point clouds. And you can see all the components of their factory floor, their assembly line here, including all the machinery, all the automobiles, and including all the components in that. And they also could actually get digital human beings into this scene and then simulate certain scenarios in this particular scene, right? What you see here is basically two artists. One of them is wearing a bodysuit, simulating certain actions or simulating certain operations in the factory, and the other one is actually adjusting the components in the factory floor, the second artist. So with the feedback, the realistic feedback from the bodysuit, the artist who is wearing the bodysuit, the second artist could actually properly place the components inside, including the height of the component, right? The height of the table, so that the setup, the whole layout is ergonomic, it is friendly, and it is healthy for the worker. Now, to do that, you need realistic human beings in the scene, right? So, what BMW did is they got digital human beings from a company called as Realization, and these digital human beings can be trained using actual data from the factory. And by placing them along with the robots, they could actually simulate the realistic working conditions of the factory where human beings and robots interact with each other, and they could also train the robots with very realistic looking scenarios. So that's something which they could do. And as you can imagine, this puts together a very large, very high quality, very complex world with all the components which will be a part of the actual physical twin. Now, when we do this, you need to also randomize the situations, randomize the objects in the scene, because a factory floor is not going to be exactly the same. The things lying around are not going to be the same. So there is a data generator, synthetic data generator, which could actually randomize, which could produce components and change the layout, change the texture, change the lighting, the conditions of the layout to different artificial ones. Now, these things, if you want to physically simulate, it's going to take a lot of time, lot of money, lot of efforts. But in Omniverse, they could actually build this entire assembly line as a single component, bring everything into this particular platform from different components, and they could also integrate real-time monitoring, remote updation of the AI models, etc., etc. So this is basically what I wanted to show you from a large-scale digital world or a digital twin creation point of view, how powerful this platform is and how complex it could be. Thank you so much.
Thank you, Shashi. Really appreciate that. Hopefully, over what Shashi has covered, you have understood the level of complexity which is there in involving in building this type of a digital factory. At any point of time, in one of these factories of BMW, there are around 5 million parts in that factory. You would need, like Shashi was telling, the level of customization required for the robots to operate out there, and hence the need for simulation. This is one factory around, I think, 3,000 odd square feet of factory in a digital mode. Over the last 2.5 years now, they've taken almost 10,000 square feet of their factories, three of them, into full-fledged digital factories, and they're looking at converting almost all of their 30 odd plants into supporting this. Rest of the world is also building virtual worlds. Amazon is using and building virtual worlds to support their entire logistic operations. Amazon Robotics is their arm for supporting that operations, and they build and train these robots also in the same digital world. BMW, we already saw. DNEG, one of the most renowned film post-production companies, is creating their full scenes and rendering them in real time and visualizing them and getting their collaborators to interact with in digital twins. A huge amount of architectural firms are using this, from Foster, HKS to KPF, or all of them using digital twins now to look at digital twins of their projects before they get them to production and the operations of it. Lockheed is using for understanding their flight simulators. PepsiCo is using this for their full-fledged back-end logistics management in their factories. Siemens is using this in their heat transfer engines, and understanding that the entire media entertainment industry is starting to leverage this. They're building from what their original environments for VFX was there to full-fledged digital twins for creating their cinematic environments and post-production environment. WPP, Sony, all of them are components of that. Telcos are also incrementally building full-fledged smart cities, or rather smart environments, for their deployment of 5G networks. Ericsson is one of those. I wanted to show you a quick glimpse of what Ericsson is doing. Ericsson is building a digital twin of the entire city to configure, operate, and continuously optimize the fleet of 5G antennas and radios. There are around 15 million 5G microcells and towers planned for getting the global deployment of 5G in the next 5 years. Ericsson is building digital twin environments to help determine how to place and configure each of their sites for the best coverage and maximum performance. They build this on Omniverse, our platform for creation of digital twins. They build city scale models that are accurate down to the materials, including the buildings, the vegetations, and the foliage. Then the network components are added to it to define the precise location, height, antenna pattern of each transmitter. Ericsson also built custom extensions, which is a capability which we'll showcase to you. Custom extensions enabling them to integrate the radio propagation data and leverage the graphics computing capabilities to quickly visualize and calculate the quality of the signal at every point in the city. Because the materials in Omniverse and a platform and in digital in any platform would need to be physically accurate, the intensity of the reflections are physically determined. Antenna beamforming and signal paths are accurately simulated and visualized. In the simulations, the lobes which you're seeing out there signify the antenna transmitters beamforming, and the straight lines are the signal paths. The colors define the intensity and the strength of it in decibels, and the data throughput from blue to which is the weakest to red at the strongest. Visualization, like as you can imagine, is a critical capability for Ericsson, and they can get their network operators and network technicians to portal into this environment with the VR devices, and they can virtually rather explore any part of the model and they correct it. And as they correct it, they can understand the changes in real time and adjust the things which otherwise wouldn't just have been possible. And hence the level of requirement for them to create a digital twin to support this type of environments. Uh, Now, from all that we have discussed now, two three things is very clear, right? The creation of these digital twins and virtual worlds is a complex team sport. Our current environment for 3D workflows are extremely tedious, and it needs a level of iterative collaboration between designers, architects, artists, and engineers. You need a large team with diverse skills, specifically skilled hybrid workforce spread across which are working across inconsistent systems and applications. Within the team itself, they might be using multiple applications which might not talk to the other applications. You would have third party supporting you on building a complex environment, and they would be using different tools. So large teams, diverse skills, inconsistency across the tools and systems and applications which they use. And then you have the vendor ecosystem filled with a variety of tools, and your design teams are absolutely plagued with the inconsistency of these tools, incompatibility of this, and then the capacity for you, rather the tediousness of you to import and export them between these tools, the mistakes you will make, the time you will lose, and obviously the dissemination of these models when any of those errors happens. Just anybody who's in this environment understand the complexities and the plethora of tools available, right? With all this, the 3D workflows are also increasingly rising complex. The demand is now very high for computer technologies like real-time ray tracing. You want AI infused capabilities for them to be behaving and interacting with these environments with the realism required to be physically accurate and simulate. So the complexity of these workflows are increasing. You then have the new challenges which are there, right? You have lived through this from the perspective of the hybrid environment of the work. Now you have people across the globe interacting on these environments, and they are in different time zones, and they are now working sometimes from their office, sometimes from their home, or sometimes from the road itself, right? And the level of flexibility you need to provide to these teams is also increasing, because earlier you could literally say, hey, come work in the office or come work in this particular environment. Now they need to work from anywhere, and from any geography for that matter. The data gravity is a looming problem, right? The data sets are increasing, they're becoming large and boundless in capacity. You need to from this virtual world to the another when you have the scene compositing going on between multiplicity of the schemes. You also have the problem of which is the single source of truth. There is file imparities, inconsistent copying, sending of these files back and forth is a consistent exercise. You have all of these challenges in building these 3D virtual worlds. In order to realize this virtual world, you obviously hence needs a platform which will enable you to connect and create these virtual worlds. You need the designers, the creators, engineers, collaborators, all interacting with a core engine where you will be able to build the physics for it, the materials which you will need inside that, the capacity to trace their path in real time and with the realism required to simulate them, and the AI enabled components to simulate, operate, and render them in real time. You would need then the microservices to be supporting that, web portals to stream them, the XR engines which will enable you to portal into the metaverse, and for the robots to portal out of the metaverse. And you would then finally need to render all of this in real time and deliver that as outcomes into workstations, into virtual reality devices, into augmented reality devices, and into web browsers where the ecosystem interacts with it, including yourself. So a platform needs to have all these components and need to have this architecture to support it. What I wanted to do over the next few slides and over this next presentation is to take you through our platform for this and show you how these components interact with each other. Sorry, how these components interact with each other, uh, and um, and sorry, give me a minute. Components interact with each other, and how the level of collaboration required is realized in a platform like this. So Shashi, I need you to come back and explain the next video on how the collaboration in a platform like this is happening, and how in real time the collaborators would be able to see this. You there, Shashi?
Um,
Shashi?
yes.
Okay,
Right.
thank you. Okay, so I'm going to play this, and maybe you do the same thing which you did earlier.
Sure. Definitely. All right. So what you see here are three different applications on the left side. and the Omniverse Create window on the right side. What exactly is happening? There is Unreal Engine which is running on top where the scene is being composited. There is Maya which is on the bottom side where a particular component is being worked upon by a different artist, and there is a texture painting artist in the middle using something called as Adobe Substance Painter. And you can see that in the right side, all these components, all these applications and the updates in that application are coming together. Whatever changes are being made in individual applications on the left side are reflecting in real time on the window on the right side in Omniverse. So this is one of the major features of Omniverse. You can have multiple applications, components of the same project in multiple applications, and people can actually see how the component changes are affecting the scene in totality. So this is one of the collaboration features of Omniverse. This is limited to applications where connectors are available. Of course, connectors is a growing ecosystem for us. So one of the examples of how it makes easy for the 3D developers and designers to come together on their projects using multiple different applications in 3D. Thank you, Nick.
Thank you, Shashi. So the complexity of this environment for each of the design teams is clearly understandable within their workflows itself, right? And now what you're seeing here is a platform which realizes to you the akin of what you see in, let's say, when we are working on a document today in, let's say, Google Docs or OneDrive. The equivalent of that in 3D is what Omniverse as a platform has realized for you. Omniverse is our platform. It's a full-fledged USD platform, a toolkit for building metaverse applications and a computer engine to run these virtual worlds. To show this creation and operation, it is impossible to show without a platform in play, and hence we wanted to demonstrate and showcase to you the possibility of what you can do in here, and also how you can quickly start building virtual world applications and virtual worlds for yourself, and collaborate with the ecosystem with this. Now, in the next video, and team, please play this video with the audio. In the next video, you will see the digital twin of a wind farm and how it saved them from, actually, just like in the case of the telco video which we showed you, in this one, they could actually calculate where to place the wind farms and also the underlying optimization of that. It's an amazing video. Please do take a look at it. Thank you.
Total worldwide wind energy capacity currently exceeds 750
gigawatts and is growing faster than ever, with an additional 650 gigawatts to be added in the next 5 years. For companies like Siemens Gamesa Renewable Energy, optimizing the configuration of each new wind farm is critical for getting the most out of their investment and reducing costs for consumers. When designing a wind farm, it's critical to place each turbine so as to minimize the effects the turbines have on each other due to the wake that they create. Accurately modeling the wake requires high-resolution, high-fidelity simulation data that is specific to that wind farm, such as the geographic location and the terrain. The gold standard for generating this data is the large eddy simulation shown here. But to run just one iteration for a single turbine can take 40 days on a 100-core CPU. And with so many iterations needed to develop an accurate model for a specific site, using CPUs is impractical. Using NVIDIA Modulus and NVIDIA Omniverse, Siemens Gamesa has been able to reduce that 40 days to just 15 minutes, approximately 4,000 times faster. This is accomplished by running the model at a lower resolution, and then, with a PhysicsML model trained using Modulus, to enhance or super resolve the data. And the results are functionally equivalent to having run the model at full resolution. Let's take a look at the same data presented in a way that clearly highlights the coarseness of the low-resolution simulation. Here, they look like pixelated blobs. In the super resolved flow field, you can see the finer vortex structures. Now that we have the simulation data, we can build an accurate weight model for the site and optimize the placement of each turbine. Thousands of iterations, accelerated by NVIDIA GPUs, are run as part of the optimization to achieve the maximum power output for each farm while minimizing the cost. And the impact is huge. When using NVIDIA Modulus and Omniverse for a typical 1,000 megawatt offshore wind farm, optimization can provide power to supply up to 20,000 additional homes, and to do it at 10% lower cost.
Thank you. I think we got a little bit cut on that video. Basically, it was showing you how they optimized it for saving the cost, and could create it such that it could optimize the engine for delivering that wind farms in the most cost effective manner. Let me quickly share my screen back and continue with the presentation. From NVIDIA side, we are building full-fledged Earth 2 supercomputer to see our future. In the rest of time, I'm not showing a video to you on it. We will realize this in the near future to give you a supercomputer to fully simulate the Earth as a digital twin of it. Now, over the next few slides, what I wanted to do was to look at the opportunity the virtual world gives to us, particularly from an India side, and the audiences, most of them are from India. So, what can you do to support the build of this ecosystem, take advantage Okay, thank you, team. I think there was an issue and you couldn't see my slides and hear me for some time, so let me restart it again. Um, I think we're talking about this. Maybe you didn't see this, so let me repeat this. I was telling that look, NVIDIA is also building its own digital twin for the Earth, the Earth 2 supercomputer to see our future. And this will get realized in the near term, and hopefully it will help us visualize our future and take the required efforts to correct it and make it better. What I wanted to do over the next few slides was to look at the virtual world opportunity from two lenses, particularly to explore how we can take advantage of this for businesses from India, particularly. How we can take advantage of it both by collaborating and building onto it, and or building it for yourself as a company, for creating an industrial scale digital twin for yourself. Two lenses, right? One is the 3D design collaboration part of it, where you are having virtual worlds created and you want artists, AI assistants, etc., to be created for this virtual world. That's an amazing opportunity, particularly for multiplicity of businesses in India itself, where you are creating tools for the 3D workflows in whichever spectrum, or assets for the 3D workflows and virtual worlds in whichever spectrum. You could look at building connectors into platforms and extensions and assets into this platform for creation of these virtual worlds. So the capacity for you to be part of that 3D collaboration, skilling yourself, building components for it is what's first part of it. On the other side, if you're a company, either integrating a digital twin for your client or for yourself, then it is the capacity for the opportunity for you rather to build an industrial twin and connecting robots into that virtual world, either a digital factory like we saw about BMW, or for any environment which we discussed in the near term. Robotics will become the next wave of AI. These are systems that will perceive the environment, reason, and plan with them. And hence, the opportunity for any type of factory, any type of environment, which we talked about earlier itself, which will have autonomous capability, needs a digital twin environment. So these are two lenses. And within this, you would need advanced tools and technologies to support this platform capabilities. If you look at this, I would like to break this, the next few slides rather, I would like to break these components down and showcase this platform to you so that it becomes apparent to you, A, what is the possibilities, and B, how you can quickly get your hands-on into being part of this ecosystem or building a virtual world for your own environment. At the core, you would need an environment where you can store, share, and collaborate. In an Omniverse, that's the nucleus. You would need then a portal that allows the content creation tools to connect to it. For us, it's the connect as a module, and then you would need a module which will enable the toolkits, which will support custom tools and extensions to connect to the virtual world creation environment. You would need simulation environment, which will be the ground truth suite for representation of the 3D scenes, and simulate them and render them in real time. You would, and rather to simulate them, you would need the computing power to support that suite of tools. You would need then a renderer to support the rendering of this in real time and scaling it to support the digital twin environment which you have created of, let's say, the full city or the factory and all its parts and components. So you need it to be supporting the technology which enables that real time rendering of it and real time physically accurate simulation of that environment. Five components: the capacity to store, share, and collaborate; the portal which enables you to connect with; a toolkit which enables you to build custom tools and extensions for it; a simulation engine which will be the ground truth; and then the rendering engine which will support the rendering of it. We built a platform for it, which is available for you, and I'll quickly share to you the exact links for this later. A open extensible platform grounds up from with USD, which will enable all these technologies and support you to build a virtual world, interact and collaborate with it. What I want to do now is to request Shashi to come back and showcase this platform and the creation of virtual world within it for you in a very quick way, and then we will share the links for you to download and play around with it and build your own virtual world. If you're an ISV or a developer partner, you can immediately leverage this to build virtual worlds or collaborate and build their extensions to the virtual world from here. So Shashi, please take over, show us the deep dive into the platform and what the platform looks like. Team, can you please bring Shashi back on and then get him to share the screen?
Hello, everyone. Let me know when I'm on stage.
Yeah.
All right. So what you see
You
on
need
the
to share, Shashi.
I am sharing.
Unni, you need to stop sharing so that Shashi can share.
Oh, okay. Okay. I've done that. Shashi, can you try now?
Is the screen visible now?
Yes, it is visible now. Thank you.
All right. Thank you. So hi, everyone. Once again, welcome. The screen which you see on here is basically the launched the launch screen of Omniverse. The first tab which you see here is news, where all the news, all the announcements about Omniverse are published. Then there is library. Library is a place where all the applications you have installed inside Omniverse is visible, right? So as you can see here, I have some 2-3 applications installed here: Create, ISXM, and Cache. If I want to install something more, I can go to Exchange. Exchange is the place where all the applications, all the connectors, all the assets, everything, all the contents, everything is listed here, right? And it's categorized as well. So if you have to install something, let's say I want to install the connector for let's say Unreal Engine, I just click on this and I can just say install. And if I want a specific version, I can actually go to all builds and I can connect a specific version and install as well. So it's that simple. Everything that you installs gets installed inside Omniverse. Now, if you are new to Omniverse and if you want to figure out how the platform works, if you want some data to do that, just go to content and there is a beautiful 20 GB scene which we have included here. You can download that and you can start playing with Omniverse using this particular scene. So that's basically the Exchange. And then there is nucleus. Nucleus is basically the core of Omniverse, where all the assets which you create in 3D are stored in USD. And nucleus is the one which basically makes it possible for you to exchange assets and collaborate across multiple applications. You can have your own nucleus on your workstation. And if you're an enterprise customer, if you have opted for the enterprise version of Omniverse, you can have a centralized nucleus in a server which has got a lot of memory, lot of CPU, and lot of storage space, where all the project teams can come together and store their assets and access them for collaboration. So that's basically nucleus. And this is the most important one, the last one, for anybody who is starting up with Omniverse. If you are new to Omniverse, there are a lot of video tutorials which you have created for every component of Omniverse. So getting started, to create and view and nucleus and all of those components are covered in detail. And there are also links to the documentation site, the forums, the developer resource center, etc., etc. Extremely good information. A lot of very detailed tutorials and documentation is kept here. So if you're downloading Omniverse for the first time, go to the Learn tab and then start exploring the tutorials, and that's the best way of learning Omniverse. So this is basically how the platform looks like. I also have an application listed here called Isaac Sim. I have just opened it so that I can show you. I know, and there are some examples in here. If you are starting up, you can actually go to the demos tab and you can just load the Leonardo demo here. There are a couple of demos which are included here in it, and just load it and you can experiment with it. And as you can see, there are a lot of tabs here. There is a console. There are assets which you have included in the in Omniverse. When you download Omniverse, these assets gets installed, bundled along with that, which you can straight away drag and drop and use it. There is flow, where you can actually simulate fire, smoke, etc. This is basically part of the physics. And there are materials which you can allocate or assign to the let's say the part which is there in Omniverse. So all of this basically are part of Omniverse. It's all here. You just have to go to the link which Unni shared and download Omniverse, and then get started with it. And all you need is an RTX enabled GPU on your workstation to do that. Right. So that's basically the platform. Unni, thank you so much. I'll give it back to you.
Thank you, Shashi. Team, I have shared in the chat box all the links for you to download Omniverse. I also shared a link for our NGC, which gives you the latest and greatest software stacks from NVIDIA for all the environments which we talked about, including Isaac Sim. Isaac Sim is a platform for simulating and creating embedded robots and training them in real-time environments so that you can put them into the digital twins and your simulated environments. Am I sharing the screen, by the way, as I'm talking, or again it's gone back? Huh? I'm sorry about that. I think this needs to get refreshed once I take over and give it to somebody else. So sorry about that. I'll reshare again. So like I was saying, like Shashi was saying, Isaac Sim is one of the applications which is out there. This is a simulation environment for the robots to be trained and be ready for operating in the real time environment which is there. Now robots will be the robotics rather the next wave of AI systems that will reason with the environment, and you can plan and execute with them. Will perceive the environment, reason, and plan their execution with it. This will be self-driving cars, embedded devices on the road, drones, everything which you can think about, which will need autonomous, will be a robot which will function in it. Now, one of the widely used and popular robots which will be the digital humans. Avatars will populate virtual worlds to help us create and build things. They will be the brand ambassadors, they will be the customer service agents, they will help us build something or interact with the metaverse itself. So you please do take a look at the avatar create a tool inside the universe and build from there. Now, what I want you to do.
Hey guys, let's wait for Uni to be back. I think there is some technical issues. So let's wait for Uni to come back. Thank you. It looks like there are some technical issues. Please bear with us.
Okay, guys.
Welcome back.
Thank you, Mario. So I was just trying to introduce you, Mario. I was basically telling them two things. One was the about robotics and our platform's capability to support robotics as a segue to talk about connectors and extensions, and then tell you that you are waiting in UK to talk to us and basically introduce you and take your help to talk about how we can build connectors and extensions in the metaverse within the platform and how we can take advantage of that. So, Mario, over to you. Thank you. Please take forward.
Thank you, Uni. Let me quickly see if I can share my screen. And just give me 1 second. Second. Here we go. You should be able to see my screen. So thank you very much, Uni. So as we were talking about virtual worlds, as you can imagine, there is a massive need for creative tools to build these virtual worlds. And you, as a creator, are going to probably use a lot of different tools. And you might want to connect all these tools to your virtual worlds. So in Omniverse, we call these things connectors. So connectors allows for multiple ways to connect to Omniverse. We have what are called bidirectional connectors, which allow multiple tools to work in real time on the same scene. So you can imagine, for example, using both Unreal Engine and Maya and Omniverse all working in concert at the same time on the same scene, even potentially from different geographical locations. You might have a remote team and a dispersed team and have multiple people and multiple tools working in concert. Then there are unique directional connectors, and we have quite a lot of those, which allows for third-party tools to actually communicate between them and exchange information, but not necessarily to work in real time. But then there is a variety of export and import tools as well, because we know that there are a lot of different ways to build 3D items and virtual worlds. Of course, we believe that USD is the way forward, but we know that currently there are a lot of different formats that developers and vendors use. So we want to make sure that we have export and import tools as well. On top of connectors, there is actually another important component, which is to be able to extend functionality of these tools and to be able to connect to multiple workflows. So we have, when it comes to Omniverse, we call these extensions. And in order to explain what extensions are, I want to go through the architecture, actually. So we have 3 different layers. We have the basic layer, which is Omniverse Kit. Omniverse Kit is a powerful SDK that contains all the main building blocks to make extensions. You have access to things like USD, the physics engine, Omni UI, which is a powerful UI toolkit. You have a Python interpreter. You have access to RTX and ray tracing, and much, much more. So Kit is very much the building block basic SDK that allows you to then go and generate extensions. Then there are extensions. Extensions are individual piece of software that can work in concert to connect to your workflow. So there are examples of very basic extensions like the content browser or the file browser or the mesh tool or texture tools. All of these are extensions. And then there are extensions that you as a creator, as a developer, or as a vendor can go and create on your own. And all these extensions then, which are the major of which is written in Python, all these extensions working in concert and being put together make apps. And those applications are usually targeted to specific workflows. At NVIDIA, we actually created quite a few applications like Omniverse Create or Omniverse Machinima, which are targeted to different workflows. Create is for 3D creators and modelers. Machinima is more targeted towards animation and movie making, for example. And then there are also microservices, which are basically extensions working without a UI. And you can also go and build them. So now I want to give you an example, a real-world hands-on example of what you can do with extensions. And one cool thing that you can do is to build extensions that can match your own workflows, as I said before. So let's imagine that you have a workflow where you need to generate items inside Omniverse, and you have to manipulate these items. So how would you go about that? So let me stop sharing this screen, and I will go back and I will share another screen where I can show you actually Omniverse working straight away. So you should be seeing Omniverse right now. And what I'm showing you here in this screen is actually called Omniverse Code, which is, as I said before, is an application based on top of the Omniverse platform. And all the components that you see here on the screen, from the viewport to the stage that I can actually go and move around, each one of these components is actually an individual extension that is working on its own. It's a piece of Python code, but it's also working in concert with all the other extensions. So for example, if I create a new mesh, you can see immediately the mesh showing up in the stage because these two extensions, the viewport and the stage, are connected, as are all other things. But now I want to give you an example of extensions. Let's say that you have a workflow, as I said before, when you want to generate items. And in this case, let's say that you want to generate pieces of furniture or a table. So I made an example here. I made a sample extension, which is activated through the extension tool, the extension manager. And if I enable this extension, as you can see here, there is a new pop-up dialog showing up here. And from this dialog, which is called Table Maker, I can actually click a button and generate a table, which is already made of multiple meshes. As you can see here, there is a table overall, a tabletop, and then all the legs. And the cool aspect of this extension, which is, again, just a piece of a few lines of Python code running, is that I can procedurally change and edit the item, and I can change the length, I can change the width. If I want, I can even, change the height. Maybe this is a little bit too much. And then I have, I can even make it disappear if I want. And then I have procedurally generated a table, and I can go here, I can duplicate this item, and then I can just move it around. And then I can go back to my original one, and I can keep editing and changing. So again, this is just a small example, but the important bit is that you can build extensions to do whatever you want with it. You can connect extensions to your own API, for example, and import your own services and use your services to manipulate the scenes. Or you can build items that generate digital twins of real-world scenario. You can control robots like the one that Sashi has shared before. So the limit is your creativity and, more importantly, how extensions can go and map to your own workflow. So I hope that I gave you a small glimpse of what is possible through Omniverse and through extensions. And we are here to answer all your questions. If you want to follow up, as Sashi has shown before, there's a lot of documentation and information, but please reach out to us. We're always happy to hear. And with this, I'll give back to Unni.
Thank you, Maria. If you could stop sharing, I'll quickly try and close this and take advantage of the limited time which we have currently. So, team, if you are not hearing me properly again, please quickly tell me. Otherwise, let me share screen again. And my last job out here is to invite you for a conference which we are building, where you can learn more about Omniverse and what's happening with AI. So, team, NVIDIA has been on this journey of creating compute to do the impossible over the last 20-25 years now. We have pioneered accelerated computing to tackle challenges that nobody else can solve. Our body of work involves us in solving grand challenges to get to simulating virtual worlds in real time. As you can see, we engineer technology for Da Vinci's and Einstein's of our time. Our work in AI is currently transforming the entire 100 trillion worth of industry. It's the engine of deep learning, the foundational technology which is powering the modern AI. Now, researchers across the world is building on this AI, this powerful force of technology of our time, which is we have ever known. More powerful technology than this, I don't think so. Our AI suite brings together skills like computer vision, conversational AI, recommender systems, avatars, robotics, and autonomous vehicles all put together, available for you. I've shared to you the course environment where you can download most of these tools, NVIDIA NGC. I've also given you a link where you can actually test out the platform for multiplicity of components, including Omniverse and NVIDIA Launchpad. Now, what I wanted to do was explain in a minute the stack as it stands together. You can think about the full stack which we provide for accelerated computing across AI and HPC in 5 layers. The underlying hardware layer, where we provide GPU-enabled systems from RTX for the graphics-enabled computing to DGX classes supercomputers for building AI factories to AGX, which enables you to do that in embedded systems in your self-driving cars or in your embedded devices. And then you have the software ecosystem for supporting this in graphics, in the entire AI space, in Kodak's libraries, and the physics enables enablement of that under physics. And then you have the platforms for HPC, AI, and Omniverse, which is now going to be discussed to create the virtual worlds. And then you have the application frameworks for everything from creating and discovering physics-enabled worlds to the full stack for healthcare to speech AI to conversation AI in video to big
Only we
NLP.
cannot hear you properly.
Oh, this is becoming a problem. Which let me refresh again.
Just give us a moment, everyone.
Okay, so I don't know where I got lost. Um, so I was
You
basically.
you were on the slide 3 billion developers.
Oh, okay, I didn't reach there. Maybe you
Okay.
jumped this line. Okay, so I was talking about the NVIDIA as a platform and what we have realized for you in as a full stack for AI and accelerated computing, and then talked about the application frameworks for that. Currently, around 3 million odd developers leverage our platform to build the possible for their world. What I wanted to do now was to invite you for our technology conference called NVIDIA GTC, the developer conference which we built for the era of AI. It's more than an AI conference. It's a global experience where our customers, brilliant minds across the world, innovators, researchers, creators, thought leaders, you name them, come and present their work over the last year, last 6 months, and how they are shaping the world with the power of AI, computer graphics, data science, etc. I wanted to invite you for this. Next GTC is in September 19th, and in your screen now, I'm sharing you the link for this conference. I request you to come and join us for GTC. This is a free conference. You have amazing sessions out there, including sessions covering virtual world creation and Omniverse. The second link which I've given you here now gives you around 30-35 odd sessions focusedly on digital twins and virtual worlds across multiplicity of environments. This link gives you curated sessions specifically for discussing the business value of digital twins, and I finally wanted to close the session by once again inviting you for GTC and looking forward to seeing you on and during GTC. There's a question out here asking, is there any Omniverse sandbox available? The answer is yes. I just shared to you the link earlier on NVIDIA Launchpad. You can go there and get it for you to support your environment, or you can just write back to us on that. So thank you, everybody. I know I've run out of time. Thank you for listening to us patiently, but I hope we've been able to cover over the session a good understanding of the evolution of the internet to metaverse now and the components required to build, collaborate, and enable a fully realized metaverse, and our vision for the same, and the standards which we are standing behind, the US Universal Screen Description Standard, and then the platform which we have enabled for realization of metaverse and virtual world environments. And finally, once again, inviting you for GTC and learning and growing along with us on this platform. Thank you very much, NASCOM team, and I hope this was useful and covered the topic.
Absolutely. Thank you. Thank you so much, Unni. Thank you so much, Shashi Kumar, and thank you so much, Mario, for an insightful session. I am absolutely glad that the audience has got an amazing, feedback for this. Everyone, we will now break for lunch, and we will be back with the next set of workshops at 2 p.m. In the meantime, I would like to highlight that we have 30 plus virtual exhibitors showcasing their products and services. Please visit the virtual booth. And I would also request you all to please share your valuable feedback with us for the workshops. Thank you. Thank you, everyone. We'll see you at 2 p.m.